click start recording, then
And
start broadcast.
yes, 3, 2, 1, go, and then I mute myself, right? Oh no,
No,
I've
you
not
have
yet.
to,
Speak,
not
right?
yet.
Okay,
The
cool.
broadcast is now starting. All attendees are in listen-only mode.
Hi, folks. Good morning, good afternoon, good evening, wherever you are. So today, our topic is going to be about cloud data replication with SQL Data Sync, presented by Warner Chavez. And I'm your moderator, Paresh Motivala from Boston. So this is the last call for PASS Summit, which is actually starting next week. And if you want to go there, you can actually make $150 discount by using the code VC15FPS6. If 20 of you use this code, then this chapter receives $150. So by going there, not only are you helping your career, but the chapter too. So there are several other community hosted events happening during the time. That is Women in Technology Happy Hour and Networking. You can actually read all of them. But my favorite one is the SQL Karaoke. It's been awesome so far. Congratulations to John Martin, Chris Yates, and Diego Nogare for winning the past board elections. And if you have, I think they should all be there in the past. You can meet them there too. So these are some of the virtual groups that belong to PASS. Or I'm sure you'll be a member of at least 2 or 3 of these. I am. The upcoming SQL Saturdays, US and Canada, there's one coming up in December, but I think we'll announce that later. That's in Providence. We have following here in the Asia Pacific region, the Latin region, and the European region. Try to join a local chapter. It helps you do a lot of face-to-face networking, in-person learning, and wait, it's free. You can present and share. And if there is no local group, which happens sometimes, then go ahead and start one. You'll have the blessings of every one of us. We'll be there to help you set it up too. Either if not from this group, somebody else. And if you have any other information or need, just go ahead and contact us on CE, contact ce@sqlpass.org. If you want to volunteer for PASS, I very highly recommend you do that. Go ahead under my volunteering section and add a few things here and there, whatever you can help us with. You can also find us on YouTube. And oh wait, that's free too. So there's a lot of learning material out there, and you would definitely learn a lot out of that. And finally, if you are not a member of PASS, which I doubt you are not, but definitely go ahead and sign up for a free membership, and you can follow us on Facebook, Twitter, and LinkedIn. The hashtag is SQLPass. If you are on Twitter and listening to Warner Chavez today, please go ahead and tweet about him. He's awesome. So finally, Warner Chavez, the SQL Server MCM, a data platform MVP, and a principal consultant at Pythian, a global Canada-based company specialized in DBA services. I've had the pleasure of meeting Warner in Ottawa. A brief stint in .NET programming led to his early DBA formation, working for enterprise customers in HP ITO organization. From there, he transitioned to his current position at Pythian, building and managing data solutions in many industry verticals while leading a highly talented team of data platform consultants. So without much ado, let's see how do I
Right click on Warner's name.
Yeah, one sec, it's coming up there. Attendees.
And make him a presenter.
Yes. Make Warner presenter. And I'm handing it over to Warner now.
And mute your mic.
Yes, ma'am.
There we go. Can you
Muted.
see the screen now? Okay, so it looks like we are good. Let's get started on this. So today's topic: cloud data replication with SQL Data Sync. Thanks for the intro, Paresh, and welcome to moderating for the DBA chapter. Quick recap. Really, Paresh already said everything that had to be said, but just to make sure that everybody's got my contact info, Twitter, feel free to reach out to me at the Warchav. That's WARCHAV. My personal blog, it's SQLturbo.com. My email, it's warner@SQLturbo.com. Feel free to also shoot me questions there. Or a lot of times people just ask me stuff, ask for my opinion, if I've done this and done that, and what advice they can give. Usually try to answer within 24 to 48 hours when I get an email like that. And also check out my my company blog. It's called Pythian. It's not just Microsoft, there's also Oracle, MySQL, Big Data, Data Science material. We're there in our technical blog, right? Cool. So let's talk about what we're gonna do today in the next 55 minutes or so. We're gonna cover the capabilities of SQL Data Sync for Azure in terms of what it does for data replication. So we're gonna go over the architecture of Data Sync, how it's different from SQL replication, what are some of the use cases for it, and we're gonna show how it's configured. And I'm not gonna configure it because it takes a while. I'm just gonna show one that it's already configured and all the different pieces. And then we're just gonna do we're gonna replicate a couple of rows and check out the behavior of the service when we're replicating data. All right. Prerequisite really to get the most out of this session is not much. If you have some SQL experience and if you have some Azure SQL database experience, nothing too crazy, you'll be able to catch on what we're doing. So first is, what is SQL Data Sync? So it is a Microsoft Azure service, and it is not hosted by the client. It is hosted by Microsoft. By that I mean that you don't have to deploy some sort of app service, or you don't have to deploy some sort of VM that's running SQL Data Sync. You basically just enable it through the portal or through PowerShell, and then Microsoft takes care of actually managing the sync service, okay? It is built on top of Azure SQL database, so that is the part where you come in, or where your resources come in. So SQL Data Sync does need a database called the SyncDB, and that database keeps the metadata of the actual data sync process. So that database is owned by you. So that database is not provided by Microsoft. So when you configure the whole thing, you say, hey, my sync database is going to be this one. And you do pay for that one, and that one has to be an Azure SQL database, okay? So that's kind of like the part where your database or your account comes in, besides obviously the actual database that you want to replicate. Now, something that is kind of cool is that Azure SQL Data Sync does do bidirectional replication. So it's not just for master-slave scenarios. You can actually do multi-master scenarios with SQL Data Sync. And it not only enables this functionality between Azure SQL databases, but it also supports a SQL Server through the use of a sync agent, okay? And it is cloud-based replication because it requires not only the SyncDB has to be an Azure SQL database, but what is called a hub, and we'll look a little bit into what that means, but one of the databases is called a hub. Think of it kind of like, maybe kind of like a publisher, if you're coming from a SQL replication background. So that database has to be an Azure SQL database as well. So if your scenario is, oh, I'm completely on-prem and I'm not going to use Azure at all, then this particular data sync process service is not for you. Then you just have to use SQL replication, and that's it, right? Something that is worth mentioning is that SQL Data Sync was first released like 3 years ago, and it was put on preview, and then there was like no activity for like 2 years, and then suddenly I want to say about July or so this year, Microsoft started blogging about it again, and they said, we're sorry that this was put on the freezer, but we are unfreezing it, and they started to put more blog posts. They released the PowerShell support. They announced the roadmap for it coming in for until the next year, going into next year. So we're looking at, the service is finally has a roadmap to not be just stuck in preview forever, and it looks like it's getting investment again. So that's really the reason why I actually put this session together, because for a long time people were looking for some sort of replication solution for Azure SQL database, and everybody was told just like, oh yeah, there's SQL data sync, but then people will come back and say, well, but is this right? Like, it looks like it hasn't been refreshed since 2015. Like, it's been in preview for 2 years with no updates. What's going on? So it wasn't really a topic that was really worth talking about when that was like the condition that it was in. But after, Microsoft came out, like I said, around 2 months ago or so, and refreshed their commitment to the service and started publishing updates, then I thought to myself, you know what? It looks like it is something worth talking about again, because we now have, the support back on, and it looks like very likely it will go general availability by early next year. So that's why I think it's worth it. And especially if any of you guys are starting to work with Azure or already have a lot of experience with Azure, and you're gonna run into some replication scenarios, then you might want to consider data sync. Okay, so this is like the basic architecture of data sync. So let's assume, we're gonna assume, for example, for this screenshot, that we're doing on-prem with cloud. So you can have a SQL Server on-prem, and that SQL Server on-prem, it will be what is called a member, and then it will sync to a database in the cloud, an Azure SQL database, and that database is going to be called the hub. Now, we can think of the hub like a publisher, but the thing is that because Azure SQL Data Sync enables bidirectional replication, then the member, which we could think of as the subscriber, can also update the publisher. So it's very similar to, if you have SQL replication experience, it will be something similar to, let's say, transactional replication with updatable subscribers, okay? So even though, we have a hub and a member, and those terms kind of lead you to think publisher subscriber, remember that we can sync bidirectionally. So there's no reason why we couldn't just say, in this scenario, if let's say our primary is on-prem on SQL Server and our slave is in the cloud because we want to use it for something else, because we have some other application there in the cloud that uses the same data, and we only enable the sync in the direction of SQL, to Azure, then even though SQL in that case is called the member, for all intents and purposes, SQL in that scenario is the publisher, okay? And as in the Azure part of the diagram, when we're moving towards the right side, that is, you guys can see there is not just the hub database, but there's only the sync database, and that is the database that, like I mentioned before, you have to pay for, and is the one that keeps the metadata for your sync service. There is the requirement that the hub database and the sync database have to be in the same Azure region, okay? And now the actual configuration of, the combination of that hub database and the member and the members, because it could be more than one, is called a sync group, okay? So, and multiple databases can be part of different sync groups. So in this scenario, we're just, simple architecture, and we're gonna look at more complicated things later on the slides. But in this scenario, we're looking at something very simple, right? So it's one hub database, one member database, one sync group, and there's only one Azure region involved, and one on-prem SQL Server involved, okay? So the important thing, takeaway here from this slide, remember, is a sync database, hub database, a member, and a sync group, all right? So let's look at what defines that sync group. So first of all is the schema, right? Which describes what data is being synchronized. So again, this is similar to SQL replication. We can pick the tables and the columns that we want to replicate, okay? Then the sync direction, like I mentioned, it can be hub to member, or it can be member to hub, and in that case, the member will be like the publisher, and the hub will be the subscriber, or it can be both, right? So we can do bidirectional. Then there's also the sync interval, which is basically how often the synchronization occurs. Now, the current minimum today is 5 minutes. So if your requirements for replication are smaller than 5 minutes, say you have to be replicating at the most with 1 minute of data lag, then SQL Data Sync today is not the right solution for you, okay? So that's the first thing definitely to think about if you're thinking about deploying this service, or if you're looking for a solution for replicating from Azure SQL Database, is that right now the sync interval is every 5 minutes. So if this is too long for your scenario, then yes, it's not the right solution for you right now. And if you have to use Azure SQL Database and your requirement is less than 5 minutes, then you're going to have to roll something on your own. Usually with something else like change tracking, for example, but that's beyond the scope of this session today.
Hey Warner,
Hopefully,
there's a quick question.
Yeah, go ahead.
Can you take it?
Now, Paresh, let's stay until the end, because usually what we do is we go through the whole material, because otherwise, we might run too long. And always, if there's time at the end, if we run out of time at the end, people can always just email me the questions and my contact, and I always follow up on them. So let's hold them till the end.
Thank you.
Okay.
Take care.
All right. So sync interval. Yeah. So how often the sync happens? Every 5 minutes. I'm thinking as we move towards GA, maybe this will improve. Maybe they will make the sync could be more aggressive, but we'll see what happens. And finally, the conflict resolution policy is basically what happens when there's a resolution that has to happen because an update or a delete or an insert is conflicting from one node to the other, right? So there is no complex conflict resolution here. If some of you are experienced with merge replication, for example, which allows different policies to be set up for conflict resolution, there's really two options, and that's it for SQL Data Sync. Is either the hub wins or the member wins. So you decide which one is the one that's going to have higher priority to the other, okay? And if you remember, there's one hub, but there could be multiple members. So what happens if we pick member wins, but we have 3 members and we have a conflict? And let's say the 3 members are actually sending me different data for one particular record. So what happens in that scenario is just based on time. Basically, the last member that has a value there is going to be the one that wins. So it's just very likely, in many scenarios, is not what you want. So to minimize conflicts, you should try to work it into your schema so that you can't have conflicts coming up, preferably, right? Because I've seen people that say, oh, no, it never happens, don't worry about it. We're not going to modify the schema. We just know nobody ever modifies server A. It's always just modified on server B. And then suddenly comes out that, somebody didn't know, and they just ran an update on server A, and it just trumped something on server B. And turns out that there were actual, actual issues that required a conflict resolution. So, for example, something that's very common that people do is to add a column, for example, that says, or origin, like an origin column, and the from server A will just write server A in the origin, and server B will write server B in the origin, and make sure that one record can't really originate from 2 different places, for example. That's one way to do it, right? And remember, that's only going to happen if you enable bidirectional, right? If you're just running in one direction, then it doesn't matter. But if you're going to run bidirectional, because for some reason you want to run in multi-master mode, then you have to be able to deal with these issues, right? Either with conflict resolution policy, or you're going to have to tweak your schema to avoid any sort of conflicts then. Okay, so like we saw in the architecture diagram, the topology is a hub database. It's got to be an Azure SQL database. member databases, those can be SQL databases or SQL Server databases. And the SQL Server databases, they can be cloud or they can be on-prem. That's not a big deal because we have the agent. So with the agent, we can connect cloud or on-prem. The sync database, that contains the metadata and log for the actual data sync process. So that also has to be Azure SQL database and it has to be in the same region as the hub database. And like I mentioned before, the sync happens between the hub and members at a 5-minute minimum. So if this is too long for you, then this unfortunately is not going to be a good technology for you right now. If they hopefully improve this over time, then maybe you can come back and look at it again. So how is it actually implemented, right? So because it's based on Azure SQL database, if you guys think about how SQL replication implemented, right? So SQL replication is implemented through agent jobs and replication executables. Replication code, a lot of it is not even inside SQL Server. It's run through a replication.exes. So it wasn't something that was going to work on Azure SQL database because there's no full-blown SQL agent. There's no concept of having, some exes trigger just for one particular database and so on, right? So for tracking the actual data changes, instead of having, let's say, something like a log reader agent, it is all based on triggers. So it's insert, update, delete triggers. And the way it works is that those changes to the data get recorded on some tracking tables that are created in parallel to your main table in the user database. So if you're dealing with a system that is insanely busy or that is super chatty and does a million changes to a record every day, then again, this is good warning. It's probably not the best option for you to use SQL Data Sync because, first of all, it's all based on triggers. So you're going to be, modifying everything. And then you're also going to be triggering more modifications that are going to be written to that side table. So that's point A, right? So you're doing a lot of activities, not like a log reader agent that reads the changes off of the log. You're actually using triggers to track the changes. And then second is that you are recording those changes in that side table. So if we have a record that, let's say, one column gets changed a bunch of times and then a bunch of records get changed, like all that activity is getting recorded on that side table, and that's going to take space, right? So it is going to consume space. Now, there is automatic cleanup of some of those records. I don't think it's modifiable right now. According from what I read online, right now it's just it has some internal thresholds, and usually the max it will keep any record that it thinks that it still needs to be there is about 45 days or so. However, if you do find it that is growing too much, you can just Google like SQL Data Sync cleanup, and there's some bloggers that have created scripts to just prune those tables manually. So it's not like completely hopeless, but if it's really in a scenario where it's just like a lot of changes are happening and these side tables are getting huge, depends. You have to see if maybe this SQL Data Sync might not be for you, right? You have to try it out. Synchronizing the data. So the hub will sync with each member individually, and changes from the hub, they're downloaded to the member. Changes from the member are uploaded to the hub. If there's any conflict resolution, then the policy is applied to see who wins or who loses, right, in terms of a change. Like I mentioned before, if the hub is the one that's supposed to be the winner, then it's just going to override whatever changes happen in the member. And if the member is the winner, that's when it can get trickier because there can be more than one member. So the final value depends on the member that syncs, the order in which the members started to sync, right? So if a member came in and moved the record, and then another one came in later in the same sync window and changed that record again, then you're going to get a different value, right? So First things first, like I said, is be really careful when deploying multi-masters so that you try to minimize the conflicts. Recommended is to actually tweak the schema of your application so that you don't get conflicts. But if you're not going to do that, then you have to be really careful that people are not updating the same record in 2 places at once, and pick a policy that actually makes sense. Okay. So let's just jump into, let's take a quick break here, and let's go over to the portal, and I have my SQL VM running as well with the sync, and I'll show you guys what the agent looks like and some of the databases and the tables and stuff. So let's jump to the portal. And everything with data sync, like I mentioned, it can be done through PowerShell, or it can be done through the portal. Here is the SQL database that I'm going to be using for the demos, just AdventureWorks Lite. And the way that this works, you just have to go to the database that you're interested in making a hub. And you see here on the side panel, it says sync to other databases. Just click there. And then you guys can see I have a sync group. It's called test. And then I have a sync agent. It's called SQL on-prem. And the sync test, test, the status is good. And the SQL on-prem is good, it's online. If you guys can see here, like I mentioned before, you can actually have a database be part of multiple sync groups, which is something that is interesting and enables some complex scenarios. It's probably best if you try to not have to use that type of functionality, because it can get complicated really quick, but it's there. Okay, so let's check out the sync group first. So I'm just gonna click on there. Okay, so you guys can see here's a couple of things. First, I can trigger the sync manually if I don't want to wait for the interval and I'm just doing some testing, or I know that I have some records and I just want to push them right away. I can just go here and sync on them. I can also click on the properties of the particular sync group, and then we'll see here I have the sync group name. I have the metadata database, which is that sync database that I mentioned to you guys. Then I have the automatic sync. You can turn this off if you really don't want to have the sync running on a schedule. I have it on and I have it set to the minimum right there, 5 minutes. And you guys can see my sync group conflict policy is that the hub wins. So basically, the change done in the Azure SQL database in this case is going to trump a conflicting change done on my on-prem SQL server. Okay. All right, and you get the log here. So there's a bunch of log information, and I'm going to show you guys later a bit on how you can get that log information, not just from the portal, but you can get it through PowerShell as well. Because I mean, it's kind of oh yeah, it's really handy to get it here from the portal. But if we were actually going to be deploying and a real production scenario, we need to have some monitoring, right? We're not just going to be sitting here in front of the Azure portal all day reading the replication log to make sure that there are no errors, right? So you can write your own monitoring script if you want, because I mean, you can integrate PowerShell with anything, send yourself an email, send yourself a text or whatever. But there's also some integration that you can do with OMS or the Azure Monitor Suite with the log analytics, for example. And there's a blog post about that as well. You can Google about it. And I have a screenshot just to show later on the slides. Okay, so let's check out the databases that are involved in the sync group, like I mentioned. So we can see here I have my hub, which is the AdventureWorks LT. You can see I have already one member database, which is this AdventureWorks LT on-prem. And you can see I have a sync agent running for it. I have the name of the database, and I have the sync direction. In this case, it's bi-directional, right? We can close that. If you guys can see here, unlike the hub, which I only have one hub per sync group, I can have multiple members. So on this same blade, I could add an Azure SQL database member if I wanted to, or I can add an on-prem database as well if I wanted to, like I added this AdventureWorks LT on-prem. Okay. Now let's check out here for the tables. Okay, so you can see here the tables that I'm replicating. This is the AdventureWorks LT schema. First of all, a very important limitation right at the top. It says tables without primary key are not supported, obviously, because then the service doesn't have a way to identify if there's a conflict if they don't have a primary key. This is not a huge deal, I believe, because most people are used to the same limitation being part of transactional replication on SQL Server, so I don't think it comes as a surprise to anybody. Once you pick the tables that you want to replicate, you also have the option to pick different columns. Now you guys can see here there are some that say unsupported or that are not ticked. So unsupported here is because the AdventureWorks Lite database has some user-defined data types. So that's one thing that is also SQL Data Sync does not support yet, is user-defined data types. So even though these are probably like, let's say, like I think, for example, a bit user-defined data type, this one, the online order flag, is probably just a bit flag under the covers. Because it's set up as a user-defined data type, that's not supported yet. So it actually shows they're as unsupported. Now these other ones that you guys can see here are blank, like sales order number, or down here below I have my total due is not clicked either, or the line total. That's because those were calculated columns. And because they are calculated columns, if I tried to replicate them with SQL Data Sync, it actually just gives you an error right away and says this is a calculated column, so it's not going to be replicated, and it just fails. So you have to make sure that to get it running, you just go in and not replicate the calculated column, which makes sense because, I mean, the calculated column is just going to be calculated from the other values that you are replicating. So there's really no point, it makes no sense that you'll be replicating the calculated column itself. Okay. Okay, close this out. And if you do need, sorry, if you do want to work with the log through the Azure portal, then you can do so here. You can say, you know, the dates that you want to see, and if you want to see only errors, for example, then you can do so as well. And you can just, for example, you can see here, I just filtered it by I just want to see errors, and you guys can see the bunch of errors that I got before when I was setting all this up through the demo and figuring out that I didn't realize that AdventureWorks LT had some calculated columns. So let me just see, for example, this one right here. It says here, the column line total cannot be modified because it's a computed column or a result of a union operator. In this case, yes, it is a computed column. So I just had to remove it, and then it started to work. Okay. So let me close out this blade, and now I'm just going to show you guys here real quick. The sync agent interface is very simple. There's not that much to do about it. You register SQL servers, so you can have one sync agent for multiple machines. In this case, I installed the sync agent on the same machine where I'm running SQL Server, but potentially you could have one sync agent for, let's say, 4 different SQL servers on-prem. As long as the sync agent can connect to those SQL servers through the network, it will work. So I can register more than one SQL server for one sync agent. I can also edit the credentials for the SQL Data Sync service to running. And so basically, you know, like you would need, in that case, you would need like a domain account that can connect to the 4 different SQL servers. And then you guys can see there's also this thing that says submit agent key. So what happens is when you set it up through the portal the first time, it actually tells you, it gives you like this really long string. And it just says, go back to your sync agent and put this as the agent key. And that is useful because what happens then, because of that really long sequence of numbers and letters, then the Azure portal knows which sync agent you're using and ties it together for the sync group that you're creating through the portal to the sync agent that you're installing on-prem. So they're tied together through that key. You can also just ping the sync service to make sure that, you know, let's say your firewall is open. connecting to Azure. And also you can see the state here for the actual connectivity to the on-prem machine. So here's my instance, and the database state is reachable. So that's it. Not a lot of science behind this sync agent, like I said, which is good. We want to make it simple. Okay. So that's so far for in terms of setup. And let's go back to the slides, and we'll come back to testing out the replication in a bit. So let's talk about the use cases that we have for SQL data sync. So when is it actually recommended, right? So we're going to talk about when it's recommended and when it's not recommended. So recommended if you have a hybrid data footprint. So if you have some data on-prem, some data in the cloud, and you don't think it's going to be changing anytime soon, you're always going to have some in both sides, then it's not uncommon for requirements to move some of it around and keep it up to date, right? It could be that an application, like I said, wants to use a part of it. It could be that an ETL in the cloud wants to use a little bit of what's on-prem and so on, right? So if you do have that kind of hybrid data footprint, you have data in both places, then SQL data sync could be a good choice if some of the other limitations that I mentioned already are not a big deal, right? If you do have something like a distributed database application, so for example, I have one application and it's distributed with 5 different Azure SQL databases, right? So I split all my clients into 5 different SQL Azure databases, but it's really just one application, and then all of the SQL, all these SQL application databases all have some common data. So what I could do, just to make it really easy to work with, if let's say I have some reference data that should be the same on all of them, I could make one of them a hub and the other one's members, and then I just make it a one direction from hub to members. And whenever I, let's say, have to refresh the product catalog, I just refresh it on that hub, and then SQL Data Sync will replicate that catalog over to all the other members, right? So that's the use case that makes a lot of sense, because it's lightweight. It's something that probably will be fine with the 5-minute window that we have right now, and it just makes sense that you just want to update one place and refresh into multiple different databases. And then the other one that could be a good recommended scenario is if you want to do cloud-based global replication. So if you're thinking about, for example, I want to keep databases synced across different Azure regions for a subset of their data. So that's the key there. Subset, if your database is just really big and you want to replicate the whole thing, that it's probably best to not do SQL data sync. You're probably best served with something else. But if you're thinking of, I need to keep this data sync across different Azure regions, and it's not a ton of data, then SQL data sync is probably a good fit as well. So what is it not recommended for? And some of these are just mentioned on the previous slide. But for example, for disaster recovery, well, data sync, like I said, works, and we saw on the demo with the portal, it works on the individual table level, right? It doesn't work on the, I just click one database and that's it, right? So DR is usually the whole database. Usually it's not just, yeah, we have a disaster, so I'm just going to recover my 4 tables and the rest of the database is just gone, right? That's not how usually we deal with disaster recovery. So there's way more efficient ways to do that. For example, geo-replication if we're doing Azure SQL database, right? For read scale, it's similar to the disaster recovery scenario. There's If you just want to do read scale of a few tables, maybe it will make sense, but usually read scale is a copy of the entire database, right? And the other thing is that usually the requirements to do read scale, kind of like with availability groups where you have the read-only replicas, usually the requirements there are to have really aggressive syncs, right? We're talking about syncs that people expect to be, under 1 minute or so. In the terms of AG, sometimes people expect, less than 10 seconds, and it has to be synced already. So it might not be acceptable to be running with a 5-minute latency that you get with SQL data sync for read scale. For ETL, it's not really an ETL because it just moves the data from A to B. There's no transformation. There's nothing that you can say like, oh, as soon as you're done syncing, please execute this procedure to transform data. There's nothing like that. So it's really not for ETL. That's definitely not what it was designed for. And finally, for migrating from on-prem to Azure, if that's what you're thinking, then again, it's not really what it's designed for, because if you want to migrate from on-prem to Azure, you can use a transactional replication with an Azure SQL database as subscriber, or nowadays you can even use the in-preview database migration service that will just walk you through the entire process of migrating from on-prem to Azure. Okay. So let's check out the possibilities with master slaves configuration. So for example, this architecture right here would be, we have a primary in Azure, and at the same time we have a slave on-prem and we have a slave in Azure. And then in that case, both the hub, the slave Azure, that's a member, and the SQL Server on-prem, that's another member, and the 3 databases are part of the sync group. Okay, so if I do a change in this case, because the primary, let's say the primary is in Azure and the other 2 are the slaves, and how we make them the slaves are basically by just enabling hub to member replication, right? So the changes will go to the hub and they will only flow in the direction of the arrows, right? So only go from hub to member or from hub to the slave Azure database. It will not, in this case, it is not bidirectional, so we don't have to worry about the conflict policy. Like simply everything that the hub does is going to trump over the 2 members, right? So that's one way to do the master slave. There's another way that we can do master slave, and it's to basically reverse the direction, right? So for example, I could have a sync direction here where I am putting my data first on SQL Server, and then from here it goes to the hub, and then from the hub it can go to another member that's inside Azure, and this could be even across a different Azure region. So it's an interesting scenario. It could come up, I guess, for example, if let's say you have a server on-prem in North America, and then you have an Azure SQL database, let's say in Europe, and you can put a hub. Maybe if you're like in the west coast of the US, you could put the hub in the east coast of the US, so it's kind of like halfway there through Europe, and get some better latency than if you were replicating all the way from the west coast of the US to Europe on an Azure SQL database. So so that's another way to put it. In this case, in this scenario, all the changes that happen on-prem will flow to the hub in Azure, and then from that hub, it will flow down to the other member that could be, like I said, in another Azure region, for example. Now let's see for multi-master configurations. So this is like the most basic multi-master config, is like the architecture that we saw at the very beginning. It's basically just a hub and a member. In this case, we're putting the member on-prem, and we're saying it's bidirectional, and that's it, right? So I can read and write to the hub database that's in Azure. I can read and write to the SQL Server on-prem, and they will replicate both of each other's changes, and the resolution of any conflicts will go depending on the policy that I selected. Now, we could do something else with this bidirectionally, the bidirectional capabilities. We could do, for example, MultiMaster of SQL servers. And what we use is an Azure Hub to coordinate, right? So we could have, let's use the example that I just said. We could have that SQL server on-prem in the West Coast US, that other SQL server on-prem in somewhere like, let's say, France. And then we want to use them as multi-masters, and we're going to use that hub database as basically a coordination point of the changes. So the French server is going to send the changes over to the hub database, who's going to replicate them down to the West Coast US server, and the other way around as well. Now remember, same thing. If there are any conflicts, it depends on what you chose. Either the hub is going to win or the member is going to win, right? So for example, in this case, because both of them are members, like France and the West Coast US, let's say, then who actually will win in the end will be whoever just refreshed their data last there in that same sync window. Okay, so it's not a good idea to deploy this. I would say, my personal professional opinion, is not a good idea to deploy this type of scenario. Let's assume again, one is US, the other one is France. I would, and they're both read and write. I would highly recommend modifying the schema then to add the origin of a row, and not allowing, let's say, the application on France to modify records where the origin says US, and not allowing application in the US to modify records where the origin says France, because you don't want to end up with basically an undeterministic way of how the data is going to behave in case of a conflict. Okay. Now, this, like I said before at the beginning, like this can get really crazy because of the capability of having databases that are part of multiple sync groups. You can do really complicated things, and you have to watch out for what you're doing. For example, you can easily create something like a circular reference if you create two sync groups. So in this scenario, we have two SQL Server on premises, and each one of them is part of two different sync groups, and each sync group will have its own hub database. And what happens here is that because we have more than one sync group involved, and because of the direction of the replication, like you know, we said, for example, that they're all bidirectional. Let's say we chose that. Then what could happen is that if I made a change on a particular server, it would flow into the other one, and that will also trigger a change in the other hub, and it will flow into the other server, and basically it would continue replicating that same data over and over and over and over and over and over and over. And because these architectures or these topologies can be really complicated, data sync does not have, at least not right now, it does not have a circular reference detector or anything like that. So it doesn't know that it's actually running around in circles. It is, at least today, your responsibility as a DBA, architect, whatever you want to call yourself, to actually make sure that in your topology, there is no possibility that a circular reference is going to happen, okay? So I made a slide just for MultiMaster because I feel that's the one that's a little bit trickier to figure out. Master slave, we all know, you know, how that really works, and most of us have implemented on-prem at some point. So things to keep in mind if you are thinking that MultiMaster is the way to go for you. You know, words of caution. So remember, there is no conflict resolution. You're either going to have the hub win or the member wins. And if you pick the member wins and there's more than one member, then it's basically going to be a non-deterministic who's going to win in every single sync window, right? Like I mentioned before, for real safety, I would recommend to add a column to differentiate a record or where it originated, right? Like I mentioned before, we could say, you know, column US, column France, and the records in the US are, sorry, application in the US is not allowed to modify records coming from origin France, right? We can read them and we can run reports on them and that kind of stuff, but we are not allowed to touch them. And it will be the same rule, obviously, in France. The application in France should not be touching or modifying records that have the origin set to US, right? And that way, we can make sure that even though we're running MultiMaster, that we don't generate conflicts, okay? There is no circular reference detection, right? So it's up to you to check it out and validate that there's no way that you can just create a loop of replication through the different databases. And finally, it's basically don't go crazy. If a design starts to look really complicated, then it's probably for the best if you really scrap it and go back to the drawing board and see if there's a better way to do things or a simpler way to do things, right? So yeah, let's not make things more complex than they have to be, basically. Okay. So summary here of a lot of the things that I've been talking about in terms of replication and data sync. So SQL replication reads from the log, data sync uses triggers, SQL uses a schedule agent, data sync, it runs as a cloud service on a schedule as well. SQL has, SQL replication does complex conflict detection, data sync has pretty simple hub wins, member wins. Replication right now can be continuous if you want. SQL data sync right now is a 5-minute minimum. SQL replication supports DDL replication. SQL data sync does not replicate DDL, so you have to make sure that you stop the sync and you manually change the schemas to make sure that they're the same, and then you can restart syncing again, okay? Big difference, obviously, is that SQL data sync can publish from either SQL Server or Azure SQL Database, where SQL Server replication is for just SQL Server. So the service cost right now, because it is on preview, the sync part of the service is free. You will pay for the sync database depending on the tier. For production use, I would recommend that you start with at least the standard one. Don't use the basic one for production. For dev test, whatever, feel free to use basic. And if you add hubs in different regions, your cost is going to go up because you'll need another sync database for a hub in a different region. And there's another reason why it will go up that I forgot to put in the slide, and it's because you're probably going to be doing egress of data, which also has a cost. It's very cheap, the egress data charge, but it does exist and it is there. Now, in terms of monitoring, I did a quick mention of this before. We can use PowerShell commandlets. So when SQL Data Sync was released, it was all portal-based. Now we have some PowerShell commandlets, and you can integrate it with the Azure Monitor. And there's a screenshot there, kind of like how it can look on the Azure Monitor once it's integrated. Like I mentioned, if you're interested on that, you can just Google Data Sync, Azure Monitor, Log Analytics, and you'll find a blog post that's got a step-by-step on how to integrate both of them. Okay, so just finishing up, let's check out just real quick, just to show you guys some of the stuff that I talked about in terms of conflict resolution and whatnot. So I have both AdventureWorks LT here. So you guys can see I have my copy here on-prem, and I also have my copy here on the cloud. And for example, if I just do a quick select on-prem of a record that we're just going to pick as reference, we can see this tax amount. I have it set to 81, okay? And if I go right now to the cloud and execute this, I see, you know, I have the same reference data. I just initialized it, and the tax amount is the same in the cloud. I have it set to 81, okay? So now we're just going to run an update, and we're going to change to different amounts the tax. So let's say, you know, the copy in the cloud, for some reason, somebody updated to have the tax to set to 100 instead of 81, and on-prem instead we had the tax set to 0 instead of 81. Okay, and if I go back to the portal, I can actually. We can go back into the sync group. Now we see in about a minute or so it's going to trigger, but we don't have to wait. You can just make them sync now. We can just wait a couple of seconds there, refresh this. And you guys can see here I have sync completed successfully in 0.55 seconds, one change applied, upload and download. So there we have conflict resolution has to take place because we basically, in the same sync window, did a different change to the same record, right? So if I run this now, you guys can see, even though I did the update here locally for the tax amount set to 0, I have the value of 100 that came from the Azure copy. The Azure copy has the same value of 100 because I had the policy set to hub wins, right? If I had the policy set to member wins, then the local amount would still be 0, and then the Azure copy would be 0, right? So that's pretty much how conflict resolution works. Now, keep in mind, like I mentioned, there is no complicated conflict resolution. It's simply the Azure part 1, and that's it. There's no like warning or error or anything. It just chugs along. It overwrites depending on the policy that you selected. So if you are going to be running in a scenario that is going to be multi-master, then you have to make sure that everything is working the way that you expected so that you don't lose any data or anything. I'll show you guys here quick, and we'll be able to see these side tables that get created. So when I enable the data sync on a VentureWorks Lite, and you can see there's a bunch of internal tables that get created, metadata for data sync, and there's 2 that you can see that are tied directly to the tables that are originally from a VentureWorks. So there's this sales order detail, data sync tracking, sales order header, data sync tracking. You don't have to do anything to them. Like I said, some people online said they cleaned them up manually because they did a lot of changes and Azure wasn't cleaning them up quick enough. So that, I guess that's something you can do depending on your volume of changes. The actual content, every time that you modify or do something to a different row, then it will get a record here. And you can see here the last change when it happened to that particular record. Other than that, I haven't really dug deep to try to debug or try to reverse engineer what all these fields are. I have the feeling that it's best to not touch any of that stuff. And just if you have to, the manual cleanup is probably where I would draw the line in terms of actually modifying or touching any of this, okay? Finally, just to show you guys real quick, if you do a search for the Azure PowerShell documentation and just do a quick search for Azure RM SQL Sync, then you will get the results of all the commandlets that are published now for SQL data sync. So you have, if you want to create a sync group, if you want to get a sync group, if you're going to create a SQL Sync agent, remember the SQL Sync agent is that utility to connect on-prem. If you need to create, if you want to get the log so you can monitor the SQL data sync, you can do so here as well, and so on. And you can add members, remove members, and all of that stuff. So all the operations are now supported through PowerShell as well, not just the portal, in case you want to actually script them and not just do portal-based work, okay? All right, so we're heading out to the top of the hour, and let's just do a quick recap. As more companies start to move to the cloud, there's more data replication scenarios that are coming up. As more companies are also starting to use Azure SQL Database as their primary PaaS offering, platform as a service, then more of these data replication scenarios are going to come up where Azure SQL Database is going to be the primary, right? So that's where I think the real value is for SQL Data Sync, and the fact that Microsoft, like I said, recommitted to the tool this year just a few months ago, and it looks like it's finally going to get a real proper GA release early next year, right? So SQL Data Sync is a good, I would call it SQL Replication Lite alternative if you're going to be using Azure SQL DB. It's not a fit for all use cases like we saw in the slides and I mentioned throughout the hour. Definitely you want to analyze it before moving forward. Definitely you want to test it out and make sure that it'll fit your requirements. However, if it does fit your requirements, it does enable some interesting scenarios in terms of geographic sync and distributed applications. For example, the one that I mentioned where you have 5 different databases for one application, and you keep the reference data just one of them and use SQL data sync so that any changes you do to that reference data automatically get replicated to the other databases. That's an interesting and powerful scenario. Geographic sync, like I mentioned, that's another interesting scenario because it also supports SQL Server on-prem. So that was where I mentioned, for example, I have a SQL on West Coast US, another one in France, and I could use Azure SQL database as the hub that coordinates the changes between the two of them. Okay. All right, so Paresh, I guess we have a few minutes here just for
Unmuted.
Sure. So the few questions. So he says, this is Curtis asking if there was a cost related to replicating from on-prem to Azure.
So there is no cost for ingress of data. The only cost will be for the cost that you already pay for your connection method, right? So the VPN or the express route, that already has a cost, but there is no cost to put data into the cloud. Is usually the cost is the other way around. It's you pay when you take data out of the cloud. And that's also why I mentioned that if you are going to do cross Azure regions, then you are going to pay for that because the data is going to move outside of the Azure region. Yeah.
And then what happens? This is an interesting question. What happens if the changes are too much and the sync won't finish in that minimum 5-minute interval? So you basically fine tune it to say 10 minutes or something like that?
Yeah. So I mean, let's say if it doesn't finish in that 5 minutes, what's going to happen is that it's going to finish. It's going to wake up and it's just going to trigger 5 minutes after the time that it woke up, right? But I mean, that's just a sign that 5 minutes is not really realistic for you, right? You need either a couple of things could happen. Like you have to find the bottleneck, right? Is the bottleneck your network? Is the bottleneck your Azure SQL database hub performance? Is the bottleneck just because you are really pushing too much data and the 5 minute is just unrealistic, right? At that point, you really have to just analyze your specific case and see what you can do about it.
Cool. Then how does it handle identity columns?
How does it handle identity columns? So what happens there is basically the service is going to do like an identity insert on in case it is just a new record. But remember, that would be only a problem when we're working with MultiMaster. If we're working with just one direction, then it's fine. It just allows the identity insert and then the new record goes in, right? On a MultiMaster scenario, I think you could end up with some conflicts for sure, right? If you if the identities start to overlap. I haven't tested that, but I can see how definitely you could end up with some conflicts if the identities start to overlap. So as always, if you're gonna do MultiMaster, you have to be really careful with how you are going to be setting up the rest of the schema. Yeah.
So that kind of segues into the next question, which is if the SQL Sync DB supports multiple groups or one sync DB per group.
So it's one sync. Let me see. No, it's multiple syncs per. Yeah. So it's one hub has to have one sync database, but you can create multiple sync groups that are using that hub, and those can share the sync database. Okay. So if you have multiple hubs, then those will need their own sync database, and you can create multiple sync groups on that hub. Okay.
Cool. And
so
I
yes,
think
as long as you keep using one hub, you can create more sync groups just with one sync database.
Then does it support temporal tables?
That's a good question. I don't know. I haven't tested it. I would be doubtful that it does, but maybe it does if you just SQL data sync the temporal table directly, because temporal creates kind of like the under the covers temporal table too. So I haven't tried it out. It would be interesting to try it out, but I haven't tried it out.
And somebody had asked earlier on when I asked you if I could ask the question way early,
Yeah.
was that if the sync, which was the subscribing database, my thing was it was in the cloud, right? That's the one in the Azure was the subscribing database, correct?
Yeah.
Okay.
The
other one
question?
is, no, the subscriber database was which one? The one on-prem or?
Oh, yeah. So that was
cloud,
just
right?
the diagram. Yeah,
Okay.
but it can be any of them. So because remember, the hub database has to be Azure
In the
SQL
cloud.
DB.
Yes.
But you can say that the member wins. So effectively, if you say the member wins, then really the hub is the subscriber in that scenario, right?
And here's a question, and I could not even guess the answer for this at all. This one comes from Cecil's PV, and the question is: does sync work with both infrastructure as service or with platform as a service database?
Yes, it works. It works with either one. So
either one, right? Okay.
if you want to run SQL on IaaS, you can have that be a member, but you can't be a hub, right? That's the only thing. So SQL can be on IaaS in Azure. SQL can be on-prem. SQL, well, for all intents and purposes, SQL could be in IaaS in AWS, as long as that can connect back to the data sync service in Azure. But the hub has to be Azure SQL database. That's where the big requirement is. That's the only one that has no flexibility, is that the hub has to be Azure SQL database.
Cool. And the last one of the day, and that one is: how long can a member be separated from the hub?
So like I mentioned, by default right now, it looks like the retention policy is 45 days. I looked around online, and that's what I found. So that's what I would go by. Basically, if the retention policy is 45 days, then I assume that you could do it for 45 days. I haven't disconnected something for 45 days and come back to try it out. Yeah. But I would assume that it's tied to the retention policy, because otherwise what will be the point of retaining that data, right?
Awesome.
I also assume or expect that as we approach GA, that retention policy is going to be configurable, because I don't see this going GA without that being a configuration item.
Okay, cool. So I think that should just about be it. Thank you so much. There are a whole bunch of people who have said thank you to you in this question session, which is awesome. And I learned a lot myself, Warner. Thank you so much. And I think we can call it the end. And if anybody has questions, just email or tweet to Warner himself. Okay?
Yeah, feel free to reach out at any time.
Cool. Thank you, folks. Have a great day. Bye.